and welcome my friends to this aviation channel. This is in aviation. I thank God for the chance to be here introducing this chapter of the ADA where we're going to learn many things, especially stuff that we won't find on internet details. My greetings and my respect to instructors, mechanics, pilots and others who are interested in this. I really want to apologize if I make mistakes, whether something's missing or my simulator doesn't fill the expectations. We are on this Boeing 737 new generation. This series that comes with several videos is going to teach us what happening really in the electrical system with the different power sources we use on the aircraft since we turn on the electrical system until we run up the engines. Noting for sure the navigation procedures, tests and safety standard procedures of the aircraft. As we know guys, airplanes of these categories have different power sources for its operation. We have the external power unit, 1, auxiliary power unit or APU, 2, engines, generators, 3, and finally batteries. Some aircraft have another source, which is called emergency generator or rain air turbine that move hydraulic components, but in this case the Boeing 737 doesn't have this small system. Therefore, it won't be explained. The standby power system is required for safe flight operation to power the most important electrical components that receive power through the standby and battery bases in the event of a partial or total electrical failure. Also, it is significant to stress that the standby power system is the first system that works when we want to put in function the aircraft. And at that time, our power source are the batteries. The function of the main battery are this: supply power to critical airplane system, AC and DC standby bases, if the normal power sources are not available. Backup power supply for the AC system control and protection. And finally, power supply for APU store. The auxiliary battery supports the main battery to fulfill the last requirements. This is the entire electrical system of the Boeing 737 in cool and dark, as you can notice around. What you need to identify here firstly are the position of the standby power system's components in the diagram. It is compound for the batteries, 2 RCCB, which are an important circuit breakers, the DC battery bus bar, the static inverter, the SPCU, which is the abbreviation of the standby power control unit, is the one that makes possible the interface among the relays used inside. The bus bars, the sensory readings for the indications in the panel 5 and others. And below, all the buses attached to the standby power system. Knowing this, the first step in order to manipulate, set up and put in function the aircraft is move the battery switch to the on position, and then the standby power switch to auto position. This is our electrical source in this moment, just the batteries, and all these buses are powered now. When we move the battery switch to the on position, the relays K1 and K8 are energized and let the power pass to the respective buses. The maintenance manual is accurate with this internal option, and for sure we can complement this internal option interpreting this specific diagram. To make sure you're reading the diagram correctly, start reading it from left to right. Identify the most important components, the main battery, and the battery switch to your left, and the K8 and the K1 relay to your right. We start from the main battery. The main battery, the travel of the positive line is directed to the battery switch by the little tiny arrows we have there. From the battery switch gets out two lines. One has a ground signal and the other a positive signal. The green line, which is the ground signal, is directed by the arrows to the K8 relay. The relay energizes, creating a magnetic field. This option gets down the relay's contactors and power the buses. The way toward the K1 relay is directed by the positive signal through different logic gates. They are tiny bipolar transistors. They are known as building blocks of any digital system. Its logical operation performed one or more binary inputs that produce a single binary output. Depending on the function of the system where the logic gates are implemented, they are going to be accompanied with other components that creates integrated circuits or well-known electronic circuits. For example, the positive line that get into the logic gate NAND have inputs 0 and 1. The binary result of this is 0. So the signal is gonna be very low to make an option, but it passes through another logic gate called NAND. It converts the signal to an output 1. Consecutively, I want you to understand in that way that the result of these electronic components have to have the expected result for K1 relay. The electronic device that have an S, an R, and a Q is known as a flip-flop. This works as a basic memory for the operation of a sequence logic. The output is 1, and in this condition the K1 relay is energized to power the respective buses. Doing the exercise again and making a recap with battery switch in on position, we have these bus bars available so far with 28 voltage and 28 amperes per hour, an operational time of 60 minutes in the bus bars fed by the batteries. Turning this selector to bad position, just we have here, we see the oscillation of the voltage that is about 24 to 28 nominal voltage, an amperage of minus 17.6. If I get in the external power unit, we're going to see that our voltage is going to be higher, even the amperage is going to be different. Understanding this, when we get in the external power unit, the APU or the engine's generator, our voltage is going to change, right? Because we have another source, and even better than the batteries. Just right here, the time we're testing, we had the batteries, just the batteries, and our voltage for that moment was just less, you know. Other thing which is very important, guys, the information given in this simulator is not accurate, but for sure we have a pretty good example for the structure here. That's on the other hand, to power the standby bus bars, we said that we must set the standby power switch to auto position. This switch has 3 positions. It's just right here. Bad position, off position, and auto position. Bad and auto position are almost the same, with different purpose, and the off position, the standby buses are on power. In the next video, the second part, we will be studying this switch much better. I hope you have gotten it. Let your comment, guys. If you have any question, please, with all respect, subscribe, don't forget it, and see you next time.